Hi, Assalamualaikum and good day everyone. In this video, I will discuss the extra exercise that I gave you the other day, and we will recap few methods that I already teach you in previous lesson on how to determine the reaction order. So, the first one we have initial rate method. And then the second one is by using Halflife method, which is you plot a graph of concentration against time. And the third method is by using linear graph method. So this one you need to refer to the integrated rate law equation. Let's have a look at example 1. So, for example 1, you are given with this equation, and then you are given set of data, and here you have for experiment 1, 2, 3, and 4. All the initial concentration for each reactant, and one last column is for the initial rate. Okay. What is the order of reaction for each reactant, and write the rate law for the reaction. Let's have a look at the solution. First, you need to write the rate law, which is rate is equals to rate constant K, and the concentration for the first reactant Br minus to the power of X, and BrO3 minus with order Y, and then concentration of H plus with order Z. So we will determine the unknown X, Y, Z in the calculation. So first, you need to compare two sets of experiment. Okay, so we will focus on the first one, which is we will determine for X. Okay, so for X, refer to the data. If you want to solve for X, so to solve X, you can consider to compare set of experiment 2 with experiment Y. Why? Because these two have different concentration, and the other two concentration you must keep constant. Okay, so I will show you in the calculation below. So the first one is the rate equation for experiment 1 with the initial rate 4.2 exponent negative 3, and then rate constant, concentration of Br minus to the power of X, concentration of BrO3 minus to the power of Y, and then concentration of H plus ion to the power of Z. So kita akan tentukan the unknown later, and then divided by experiment 2. So here are the details and data for experiment 2. This is the rate 2.1 exponent negative 3, and rate constant K, the concentration for the first reactant 0.1 X, and then 0.2 for H plus ion as well. And then we can use to cancel off all the unwanted information, and then you just compare to solve for X. So this one will be 2 to the power of X, and then use law of log and you log both sides, so kamu akan dapat x is equals to 1. So the order of reaction is 1 ataupun first order with respect to Br minus. So use the same method to solve for y and z. For the order of reaction with respect to Br minus, it is first order, and then for the next one, the order of reaction with respect to BrO3 minus, from your calculation by comparing experiment 1 and experiment 4, you will get the order of reaction is 2. And for the third one, which is the order of reaction with respect to H plus, it is order 0.5. So from the calculation, when you compare experiment 3 and experiment 1 and you substitute the value, you simplify and then log both sides, and then you will get your answer. Z is equals to 0.5. So your answer, just leave it like this and do not round off to the nearest whole number. And for your rate law, rate is equals to rate constant K, Br minus, concentration of Br minus to the power of 1, and then BrO3 minus to the power of 2, and concentration of H plus to the power of 0.5. So this is the rate law for your reaction for this example. For the next example, you are given with this equation and few sets of data, and you need to determine the value of R, S and T, and you are given with the rate law. So from the question, you are given this rate law and there's no information about H plus. So what does it mean here? It is first order. For IO3 minus, it is first order, and for I minus, it is also first order, but for H plus, it is 0 order. So now you can use the information given to find the value of R, S and T. So first thing, you need to find value of rate constant K. How? You can substitute into rate law, this rate law, and you just substitute the value from the experiment 1. Okay, when you have the rate law given, you can deduce that the order of reaction with respect to IO3 minus here is 1, first order, and the order of reaction with respect to I minus is also first order, and the order of reaction for H plus is 0 order. That's why we didn't write anything here. And to find the rate constant K, you just substitute the value, so we can use data from the experiment 1 and substitute the value to solve K, and you will get the value 12 per molar per minute for rate constant. And when you already have the rate constant, you can use it to find value R, S and T. So to find value of R, we can refer to the set of experiment 2 here, and you will get the concentration of R is 0.01 molar, and for S, when you substitute the value, and you can find the value of S here, which is 0.02 molar. And then for value of T, the rate for experiment 4, you just substitute the value of rate constant, concentration for each reactant, and you will get the rate of the initial rate for experiment 4, which is 4.8 exponent negative 3 molar per minute. So the next method is half-life method. We assume that this is your equation. From reactant A will produce product. So for zero order reaction, when you plot the value of concentration against time, okay, so when you want to use half-life method, we will plot graph of concentration against time. Okay, usually it is directly from the data given to you. So if you plot the graph of concentration against time, and then you obtain a straight line like this, so it means that from the graph we can deduce that the order of reaction is zero order. Okay, and you can see the pattern of the half-life. The trend is, so the first half-life, half from the initial concentration here, so half is 0.1. so when you refer to your graph, you draw a straight line from the concentration, half from the initial concentration, and then you find the time taken for the initial concentration to reduce by half. And then when you have the value here, and you can compare with the second half-life. So initial concentration divided by 4, you will get this value 0.05, and then you will get the second half-life here. So this is the first one, and then this is the second, and you can also find for the third half-life here. So if you can see the pattern or the trend of the half-life, it will decrease with decreasing the concentration. So you can deduce from the trend ataupun the value of half-life, it is zero order when you have the value of first half-life. Let's say I use X. So let's say this is around 30 something, and then the second half-life here, it is half from the value of the first half-life. So next is first order reaction. So first order reaction, when you plot the graph of concentration against time, you will get a curve. Okay, so let's say when you plot the graph, let's say you just have points until, so the first initial, second, third. Okay, so let's say you only have 1, 2, 3, 4, 5 data. So when you want to do the line, the curve for this graph. So make sure you pull your pencil or your pen from the initial and then straight away you draw a line until approaching the x-axis. Okay, so just tarik your line approaching the x-axis walaupun di sini tak ada data. So let's say if you want to find Half-Life, kalau tak cukup data, it's okay because from graph kita boleh tentukan. Just make sure you draw one curve, smooth curve to get the Half-Life. Okay, so I will show you later. And then for the first Half-Life, okay, half from the initial concentration, you will get here first Half-Life, and then the second Half-Life, and then the third Half-Life. So you can see the trend here. Okay, let's say the value here is x, and then the same goes to second Half-Life, this one. Okay, so the differences is also x, and the third Half-Life is also the same, which is constant. So let's say the amount here is 10. So all of the Half-Life is also 10 minutes. So from there we can deduce, since Half-Life is constant, so you can also write the value, let's say 10 minutes. Therefore we can say that the order of reaction is first order reaction. Okay, so what if when you plot your graph, when you draw the curve, you get value, let's say here you have the value of first Half-Life 10, second Half-Life maybe 11, and then the third Half-Life maybe around 9. Okay, so when you draw graph, it is impossible for you to get a very nice curve. Okay, so what you can do here, okay, let's say you want to deduce whether it is first order ataupun second order. So apa yang kamu boleh buat here is you take the average, so 10 plus 11 plus 9, and then divide it by 3 to get the average Half-Life. So when you get the average Half-Life is near to the number of Half-Life for each. So let's say in this case I got 10 minutes. Okay, so you can also assume that the Half-Life is almost constant for each of the first, second and third Half-Life. Therefore the order of reaction we can say that it is first order reaction. Okay, so biasanya kamu boleh gunakan this trick untuk tengok sama ada dia punya gap here ataupun Half-Life ni adalah constant ataupun tidak. Okay, kalau dia punya value dekat-dekat, so you can say that it is first order lah. So let's say kalau kamu buat graph, let's say your value here is 18 for the second Half-Life. So when you find ataupun cari calculate the average, kamu akan dapat value yang agak jauh daripada 10 minutes. So from there you can see that it is not a first order lah. Okay, so let's have a look at second order punya reaction pula. So for the second order, okay, you can see that dia punya curve berbeza dengan first order punya reaction. So when you want to find the first half-life, so normally for the first half-life untuk second order, let's say di sini value dia adalah 5 minit. Okay, and then the second half-life usually dia akan double up jadi 10 minutes, and then for the third half-life, okay, it will be greater lah. So you can see the trend that the first half-life is, let's say we use unknown x, the value of x, so the second half-life will be double. Right, so if you see this trend ataupun pattern, you can say that since if you want to prove ataupun show whether this is second order, so you can write this conclusion: since the half-life, since the second half-life is double from the first half-life, therefore we can deduce that the order of reaction is second order with respect to the concentration of your reactant lah. Okay, so I hope by now you can differentiate between zero order, first order and second order. So the first example for half-life method, you are given with this data, time in minute and concentration. So plot the concentration, graph of concentration against time, and determine the order of reaction and then the rate constant. So first you need to plot graph concentration against time. Okay, so for graph, normally the marks allocated here is for axis with correct labeling, and you must write the unit here. So for concentration, kalau untuk concentration lah, mesti ada unit molarity. Okay, so untuk time mesti tulis in minute, and then untuk labeling, use the correct scale, and then plot your graph and draw the curve nicely and make sure it is smooth. So kalau kamu guna pencil, just tarik sekali saja, like this. So just tarik one time to make sure you get the smooth curve. Okay, jangan buat from dot to dot to dot like that. Okay, kalau tak kamu tak akan dapat smooth curve lah. So just tarik from end and then draw it approaching the x-axis. Okay, and make sure your curve touch most of the point on the curve. Okay, so kalau biasanya kalau tak dapat touch all the point, make sure you get line of best fit ataupun curve yang touch almost all the point lah, with most point. Okay, so okay, so from here kita boleh cari dia punya first half-life. So untuk first half-life, it is around 20 minute. Okay, so your half-life ni depends on your curve. Okay, sometimes kamu akan dapat maybe 21 minutes or 22 minutes, but not far from this range lah. Okay, and then the second one, okay, kalau curve kamu cantik, kamu akan dapat exactly 20 minit, or maybe it can be around 21, 22. Okay, so kalau kamu tak dapat value yang sama, use my method just now untuk tengok whether you can see the average, but that's only for first first order punya reaction lah. So kamu cari average. Okay, so from the plot, from the graph, you can see that the half-life is the same. Therefore, you can deduce that the order of reaction is first order reaction. So the half-life is constant and does not depend on the initial concentration. So you just write this one lah, yang penting. And therefore the reaction is first order. Okay, mesti tulis ayat ni. And then you can use this formula. Okay, since you already know that it is first order, so you can use formula half-life for first order, which is half-life is equals to ln 2 over k. Okay, so rearrange them to find rate constant k. Kamu akan dapat this value. Okay, so for linear graph method, zero order reaction is concentration against time, and when you refer to this integrated rate equation, so y equals to mx plus c. So y-axis kamu here is concentration against time. So you can directly plot daripada data given biasanya lah. Okay, so it is the same graph with half-life kalau untuk zero order lah. Okay, and then for the first order, okay, the integrated rate equation is ln A yang guna ln, and then rearrange them equals to y equals to mx plus c, and then kamu akan dapat y-axis sepatutnya ln A, so ln concentration of your reactant. So if you are given data for concentration, let's say usually data given in the question akan bagi concentration again and time. Okay, so you need to change this data to ln concentration for each of your data, and then against time. Okay, so for your y-intercept will be ln concentration N0, which is your initial concentration. For second order reaction, your integrated rate equation is this one, and when you rearrange them to y equals to mx plus c, it will be like this. Okay, so this is your y-axis, mx plus c. Okay, y-axis 1 over A, concentration of A, and then your x-axis is time here, and your y-intercept is 1 over A0, which is your initial concentration. So here you will get a positive slope. So garis your linear graph will be pointed ke atas since it is 1 over concentration. So it is reverse to your other two graph, zero order dengan first order. Okay, when you want to find the gradient ataupun the rate constant, you can use data from your graph and then cari dia punya gradient untuk dapatkan value of rate constant. Okay, based on this example, okay, if you refer to this example, the question already asks you to plot a graph of 1 over concentration against time. Okay, so from here kita tahu kita nak prove that it is second order reaction. So your graph will be 1 over concentration against time, and then your linear graph ataupun line will be upwards like this. Okay, so if you plot your graph, you will get like this. Okay, for chemistry, actually you can do this. Okay, so it not necessarily to start from 0. Okay, so you can terus straight away start daripada 40 ataupun 50 lah. Okay, so you will have a bigger scale untuk your graph and it will be better lah untuk exam. Okay, so kalau kamu plot daripada 0, in your graph paper A4 tu kamu akan dapat straight line, linear line kamu tu sangat-sangat kecil. Okay, it won't be more than half daripada kamu punya graph paper pun. So in chemistry, kalau dekat sini tak semestinya start daripada 0 pun boleh. Okay, for the answer why it is second order, so you can say that based on the plot of 1 over concentration against time will give ataupun akan hasilkan straight line graph, therefore we can say that it is second order reaction. Okay, so macam tu je how you explain based on the graph that you plot. And then the value of rate constant, so from gradient of the graph. Okay, it is much easier. You can choose 2 points from the table. Okay, tapi kamu mesti kena tunjuk juga the calculation. So ini y, so y2 minus y1 and then x2 minus x1. So you will get the gradient untuk the graph, from the graph. So it will be 0.873 per molar per second.